Today we are going to talk about the admixtures. Last time we discussed the ingredients of the concrete. We say that in order to make concrete, you need to have water, you need to have cement, you need to have sand, and you need to have gravel. And also we say that sometimes we add what so-called admixtures. And the admixtures are ingredients other than the water, the cement, and the sand, and the gravel. Any component other than those is going to consider as admixtures. So admixtures, it may be added to concrete immediately before or during the mixing process. And the purpose of the admixtures in order to enhance specified quality to plastic mix or hardening concrete. Plastic mix, that means the concrete is still fresh, while the hardened concrete, that means the concrete is in solid state. So we add admixtures in order to improve qualities, whether the concrete is still in plastic state or solid state. We have many types of admixtures, and the admixture is going to be classified by the following chemical and functional physical characteristics. The first type, we have the air-entrainers, and then we have the water reducers, and we have the retarders, and we have the hydration controller admixtures, and we have accelerators, and we have specialty admixtures. In this lecture, we are going to talk about each and every one of them. But before that, we need to know what the PCA, the Portland Cement Association, says about the why we should use the admixtures. They specified 4 major reasons for that. The first reason for using admixtures to reduce the cost of concrete construction. Since we are going to improve some properties of the concrete, that may going to help us to save some money. Also to achieve certain properties in concrete more effectively than other means. And the third reason is to ensure quality of concrete during the stages of mixing, transporting, and placing, curing in adverse weather conditions. So we have many stages for the concrete. We need to mix the ingredients together. We need to transport the concrete from the plant to the job site. So we have the transporting process. We have the placing process. We are going to take the concrete and we are going to cast the concrete into the specified structural element. Then when the concrete became solid, then we are going to start the curing process. We need to maintain the hydration process by many methods so that the strength of the concrete is going to increase by days. The last reason for using admixtures, we use admixtures to overcome certain emergencies during construction operation. Sometimes an accident may take place during the casting of the concrete, and we are going to lose a lot of amount of concrete. But if we are going to use admixtures, we may save that loss. So let's get started with the first type of admixtures. The first type of the admixture is the air-entrainers. The air-entrainers is the chemical admixture. When we mix the cement with air-entrainers, then that air-entrainers is going to produce tiny dispersed air bubbles into the concrete. They are going to look like that, small bubbles into the concrete when I'm going to use air-entrainers. So what is the benefit of the air entrainers? We know that in some areas, especially in the cold regions areas, we have voids inside the concrete. And when these voids is going to fill with water, and when the temperature is going to increase, we know that when the temperature is going to, the temperature is going to decrease, then the volume of the water is going to expand, because the water is going to be solid. It's going to convert to ice. So if the water convert to an ice, then the volume of the ice is going to be 9% more than the volume of the liquid water. And that is going to exert pressure, internal pressure. And as a result, we are going to get those cracks. So in regions where cold weather is expected, we usually use air entrainers. So we are going to introduce tiny dispersed air bubbles inside the concrete. When the water is going to convert to an ice, so the water here try to escape outside because the turning process. So when I'm going to have those tiny dispersed air bubbles, the water is going to escape here. And as a result, the change in the volume is not going to cause any cracks. So the air entrainer pockets, these pockets here, provide a relief system for internal ice pressure. We said that we are going to have internal ice pressure because the volume of the ice is 9% more than the liquid water. And by that, we are going to accommodate the volume expansion caused by freezing water. So when I'm going to use air entrainers in cold weather, the water expands as it freezes, causing the internal stresses that cracks the hardened cement paste and greatly reduce the durability. When I'm going to have cracks, of course, the concrete is not going to live longer. So by using air entrainer, that is going to provide space for the water to go as it expands. And of course, the air entrainers is recommended for all concrete exposed to freezing. The air entrainers will not only help us to provide relief system in case of freezing, but also is going to improve the workability. The workability is how easy you can deal with the concrete. And also is going to improve the resistance to de-icing chemicals. In cold regions where we have snow, we are going to use de-icing chemicals on the roads so that the ice is going to melt. And that is going to improve the traffic movement of the cars. And also is going to improve the resistance to sulfates and alkalis. But like you can see here, when I'm going to use the air entrainers, the percentage of the voids is going to increase. And if the voids is going to increase, then the strings is going to decrease. So it's expected to have decrease of about 20% when we are going to use air entrainers. But that can be compensated with the lower water cement ratio. So you need to use a water cement ratio less than the normal, so that you are going to compensate for the loss of the strength. The other type is the water reducers. We know that the workability of fresh or plastic concrete requires more water than it's needed for hydration. We explained the hydration process when we talked about the cement, and we said that we need a certain amount of water for hydration. But we are going to increase that amount of water so that we can the workability. So we need more water than it's needed for hydration. And we discussed that the excess water beyond the hydration requirement. So if I'm going to put water more than the it's needed for hydration, this is going to be bad for all desirable properties of hardened concrete. So it's going to be detrimental to all desirable properties of hardened concrete. The strength is going to decrease, the durability is going to decrease, the permeability is going to increase, and so on. So therefore, we develop the water reducing admixtures. So the purpose of the water reducers, we need to have workability, but at the same time, we need to maintain the quality by not increasing the amount of water. So the water reducers increase the mobility of cement particles in the plastic mix. And by doing this, we are going to have workability to be achieved at a lower water content. There is no need to increase the water content if I'm going to use the water reducers. The water reducers, it has many levels. We have the conventional level, we have the mid-range level, and finally we have the high-range level. And it's known by the Superplasticizer. And nowadays, we are going to we use the Superplasticizer in our daily life when we are going to deal with concrete. I need to explain to you how we are going to measure the workability of the concrete. Here we talk about the workability a lot, and we say that the workability is how easy I'm going to deal with my concrete, and I'm going to explain to you how we are going to assess the workability of the concrete at the job site. So in order to measure the workability, we are going to use the slump test. In the slump test, I'm going to use this conical shape, steel conical shape, like this one here. This diameter is smaller than that diameter. Then I'm going to fill that conical shape with concrete in 3 levels or 3 layers. Layer 1, and I'm going to provide compaction, 25 strokes. Then layer 2, another 25 strokes, and the final layer with 25 stroke. The stroke is going to provide compaction. I'm going to decrease the voids. Then I'm going to release that conical shape from the concrete. And as a result, we are going to have a decrease in the height of the concrete. Then we are going to compare the distance here, the original distance, with the final distance after I'm going to release the conical shape. This distance from here to here is we call this the slump. So if the value of the slump is going to be larger, it means that the workability is going to be better. Okay, so if I'm going, for example, if this value is here, that means the workability is not good compared with this slump. So usually we are going to assess the workability at the job site. So let's see how the water reducers is going to improve the workability. So here we have the test after we release the conical shape from the concrete. Like you can see here, nothing has been changed. If you compare the initial height with the final height, you are not going to notice any slump. So in this case, no water reducer has been used. Then in the second case here, we used conventional or normal water reducers. If I'm going to compare the initial height with the final height, you are going to have a slump. That means the workability improved in this case. Then here I use the mid-range water reducer. Like you can see here, the final height is close to the ground, which means that the workability has improved more than this case. And in the final case here, like you can see, the concrete is just like liquid, because here we use the high range water reducers, the Superplasticizer. So the water reducer is going to improve the workability, but at the same time, we are going to maintain the quality by maintain the lower amount of the water cement ratio. We have many purposes in order to use the water reducer. Not only improve the workability, but also we can increase the strength, and also we can reduce the cost. Let's see this example here so that you can understand the three ways to use the water reducers. We are going to improve the workability, or to increase the strength, or to reduce the cost. Let's see this example here so that you can understand this concept. First, here we have the base mix. We are going to compare the case. Let's assume this one is the case 1, and this is the case 2, and this is the case 3. And this one is the control specimen. We are going to compare case 1 with the base mix, case 2 with the base mix, and case 3 with the base mix. So in the base mix, we have 300 kilogram per meter cube. The water cement ratio is 0.62. And when we assessed the slump came out to be 50 millimeter. And the compressive strength after 7 days came out to be 25 megapascal. And after 28 days, the compressive strength came out to be 37 megapascal. In the base mix, we didn't use the water reducers. So the base mix without water reducers. Now I'm going to use the water reducers without changing the cement content, and I'm going to keep the water cement ratio as it is. So this one is as it is, and this one is also as it is. I only add water reducer. So what happened here? The slump improved, and I got almost the same compressive strength. So in case 1, I improved the workability using the same water cement ratio. So in case 1, I managed to improve the workability with the same water cement ratio and the same cement content. In case 2, here, I'm going to use a lower water cement ratio. In the base mix, I used 0.62, but here I use 0.56. So here I use lower water cement ratio, and I add water reducers. And as a result, the slump test is the same as the base mix. But what happened to the strength? The strength increased. Here I have 25, here I have 34. Here I have 37 and here I have 46. So here I used the water reducer not to increase the slump, but to use a lower water cement ratio. And you know that if I'm going to use a lower water cement ratio, the compressive strength is going to increase. The final case here, again, I'm going to use water reducer, but in this case, I'm going to decrease the amount of the cement content. For the base mix, the amount is 300 kilogram per meter cube, while here the amount is 270 kilogram per meter cube. So I decrease the amount here. I maintain the same water cement ratio. When I use the water reducer, the slump came out to be the same as the base mixed, and the strength is almost like the base mix. But what I have gained here, I decrease the amount of the cement content. And we know that the most expensive ingredient in the concrete is the cement. So when I reduced the content of the cement, as a result, I reduced the cost. I hope you understand the concept of the water reducers by this example. So let's talk more about the superplasticizer. We mentioned here the superplasticizer is a high range of water reducers. And the superplasticizer or the high range water reducers can either greatly increase the flow of fresh concrete or reduce the amount of water required for given consistency. For example, adding a superplasticizer to a concrete with 75 millimeter slump can increase the slump to 230 millimeter. So if you have a concrete with 75 millimeter slump, if you are going to use the superplasticizer, then the slump is going to be 230 millimeter. Or you can, the original slump can be maintained, so you can maintain this one, but you can reduce the water content to 12% to 30%. Reducing the amount of mixing water is going to reduce the water cement ratio, and as a result, that is going to increase the strength of hardening concrete. Now, the high strength concrete in the order of 70 to 80 megapascal compressive strength or more can be produced when superplasticizer are used. The normal compressive strength for the concrete is between 20 to 40 megapascal. But now, because of the superplasticizer, we managed to achieve an order of 70 to 80 megapascal compressive strength. So if you want to produce high strength concrete, it's a must to use a superplasticizer. When the superplasticizers are used, the fresh concrete stays workable for a short time, between 30 to 60 minutes. So you have this period before rapid loss in workability. So superplasticizer is give you a room between 30 to 60 minutes for good workability, and then you are going to lose that workability. And we can use superplasticizer at the job sites. So when should I use a superplasticizer? Like we can see that a lower water cement ratio is beneficial, because that is going to increase the high strength concrete and reduce the porosity. So you can achieve lower water cement ratio by using the superplasticizer. Also, sometimes you have to place concrete in thin sections, which means that sometimes you are going to be in a situation where you have a large amount of steel close to each other, like a jungle of steel. So in these cases, it's difficult to place the concrete inside the job site. So if you use superplasticizer, the workability is going to be good. Then the handling the concrete at the job site is going to be easy. Sometimes the thickness of the section is very small. For example, when the section is very thin, if you are going to cast the concrete, then that job is going to be difficult. But if you use superplasticizer, the concrete is going to be like a liquid water, so it's easily to fill the gaps. And also nowadays, we are going to use bumper, or we are going to use a bump in order to bump the concrete using the truck inside the site. So here we have a bump in order to deliver the concrete from the truck to at the job site. And if the workability is bad, then the bump is going to be blocked by the concrete. So if you are going to use a bump, then it's important to use the superplasticizer. Also, the compaction or the consolidation of the concrete is going to be difficult without the superplasticizer. So if I'm going to use a superplasticizer, the compaction is going to be very easy. We have also the retarders. We use the retarders in order to delay the initial time. Some construction conditions require that the time between the mixing and placing or finishing the concrete to be increased. So some construction work, it needs much time from the plant of the concrete to deliver the concrete from the plant of concrete to the job site. So in these cases, retarders can be used to delay the initial set of concrete. In the previous lectures, we explained the idea of the initial set and the final set. And even we got a lab talk about how to determine the initial set and the final set of the concrete. So retarders are used for several reasons, such as the following. For example, the first reason for offsetting the accelerating effect of hot weather on the setting of the concrete. In hot weather condition, the initial set is going to be shorter than the normal conditions. So in these cases, it may be better to use retarders. And also sometimes we have special placement or unusual placement that is going to take a lot of time. So in these cases, it's better to delay the initial set, because after the initial set, dealing with the concrete is going to be very difficult. And also sometimes we have special finishes. We have types of finishes that takes time. So also that is going to provide time for these conditions. The retarders can reduce the strength of concrete at early ages. So if you are going to use the retarders, the strength of the concrete is going to be lower than the normal at the early ages, which means that from 1 to 3 days. Other retarders increase the time required for the initial set, but reduce the time between the initial and the final set. So you are going to increase the initial set, but the final set is going to, the time between the initial and the final set is going to be reduced. Thus, you have to be very careful using the retarders. It's better to experimentally during the mixing design. It's better to observe the effect of the retarders. So before using the retarders, you need to determine the initial set and the final set and the compressive strength. Also, we have the hydration controllers. I'm going to stop at this point here. If you have any questions, I'm going to give you a time for questions. I'm going to stop at hydration controllers. I'm going to quickly talk about it because we have similarity between retarders and hydration controllers. So the hydration controllers have the ability to stop and reactivate the hydration process of the concrete. So the retarders is going to delay the initial set, but the hydration controllers is going to stop the hydration process itself. And also it has the ability to reactivate the hydration process again. So it consists of two parts. We have the stabilizer and we have the activator. The stabilizer have the ability to stop the hydration for up to 72 hours. So that's for very long time. And when I use the activators, I'm going to reestablish the normal hydration and the setting. And that it could be useful if an emergency take place on the site. For example, you prepare a lot of amount of concrete and an accident take place at the job site. Then you have a large amount of concrete. What are you going to do about it? If you are going to fix your accident, then the concrete is going to turn to solid state. Or you can throw away the concrete. But if you have hydration controllers, you can stop the hydration process up to 72 hours. So this admixture is useful in extending the use of ready mixed concrete when work at the job site is stopped for various reasons. And also it's useful when concrete is being hauled for a long time. So I'm going to stop here. Next time, I'm going to talk about the accelerators. The accelerators is opposite to retarders. And also we are going to talk about the supplementary cementitious material. Those materials are byproduct. They should be thrown away. But since they have cementitious properties, we are going to replace the cement with a certain percentage using the supplementary cementitious material. So I'm going to stop here. If you have any questions,